Now let's look at, in case we want to generate not just one NPV for a project, we are looking at a range of net present values, because net present value is nothing but the present value of future cash flows. And future cash flows generally are estimates. So they cannot be bullet point numbers. They are always ranges. So which means even my net present value also could be a range. So how do I really get into this typical construction of the distribution or the ranges of these net present values? There are two commonly used mechanisms for the same. One being the scenario analysis, where we create different kinds of scenarios, evaluate the scenarios for arriving at NPV. The other is a complete simulation based stochastic models, which are typically run using the computer systems itself. So these two models are very commonly in use. Each one has its own set of advantages and disadvantages. Coming to the scenario analysis, I create different scenarios. Probably for each dimension, we are going to create a different scenario. Probably the status of economy, good, medium, bad, right? And again, in combination with the status of the industry, good, medium, bad. Now, if I see the combinations of these two, I'm going to get 9 possible situations. Good, 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 medium, good, bad, medium, good, medium, 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 bad, something like this. I'm going to get 9 different possible scenarios. Now, what we are typically saying is, I'm creating such kind of scenarios of the future. In the future, if the economy is going to be good, but the industry is going to be medium performing, that's a scenario for me. And for each of these scenarios, in this case, I have 9 scenarios. For each of these scenarios, I'll try to understand what is the probability of this particular scenario occurring. What is the probability that the economy will be good, but the industry will be medium? So I'm getting the various probabilities of occurrences for all of them, and each of these probabilities for each different combinations of the risk I am taking. And probably in this, okay, now if the economy comes here, I may say that the result, that the profit for a company or that the cash flows can be anywhere between 30 and 40. Now, what I can very well take is, okay, the probability of this occurring is, let's say, 20%, and this has a 60% chance that I'll get 30 and a 40% chance that I'll get 40. So in this case, I'm getting the expected value to be somewhere around 34. Now, the way we are working out is the probability of the good and medium is going to be 0.2, and in case that occurs, the future cash flow is going to be 34. The same way we are going to do the probabilities as well as the typical values or NPVs that are possible in each of the scenarios, and then solving it to find out the expected value. And what could typically happen is the number of sub scenarios. Now in some cases I can have different scenarios for revenues, right? Very high revenue, moderate revenue, low revenue, poor revenue. I can have for operating expenses, again different kinds of scenarios. For cost of goods sold, I can create different kinds of scenarios. And if I'm taking all these combinations, probably it is like number of scenarios for revenues multiplied by number of scenarios for operating expenses, number of scenarios for cost of goods sold. Those many scenarios are getting generated. And the point is very simple. For each of these scenarios, try identifying the probability of each of this scenario. What are the going to be the typical cash flows in case this scenario is going to occur? Try computing the net present value of each of the scenarios. Now let's say if I say 34 is going to be the cash flow for the next 5 years, if this GM is going to occur. But if MG is going to occur, means economy is medium, but the industry is, let's say, it is 50 bucks that is going to come out as the cash flows for each of the next 8 years. Now, what we are simply trying to do is find the NPV in this case, find the NPV in this case. Now take what is the probability of occurrence of this, multiply it with the NPV, take the probability of occurrence of this, multiply it with NPV, and overall see what is going to be the net NPV. But rather than just looking at one single net NPV, we are also looking at the individual NPVs also. Wherever they are all positive, we are not that much bothered. But wherever they are negative, it indicates that when the economy and industry go into this particular situation, means when this scenario comes up, though this scenario has a very little probability of occurrence, which is seen through the probability, but still, if this scenario is going to occur, it is going to be an unfavorable project for us. Now, this is where they'll see if this number is very, very small, they are still going to accept it. But if this number is very, very negative, then it means even if there is a slightest frequency chance of occurrence of that particular scenario, the company doesn't want to take the risk. Though it's a low frequency but high severity kind of an event, though the frequency is much lesser, the company does not want to ignore it. It will take this risk as a priority and come out with a proper action plan. So a scenario analysis typically helps in terms of seeing not just one average value which is positive, but they are going to look at all possible values that are occurring, looking at in all scenarios what is the NPV that is coming out, what is the worst case wherein the unfavorable stuff are turning around, what is the best case if the economy touches this particular situation, economy is good and the industry is good, the NPV is going to be significantly higher. So all possible combinations are looked at. Any of the unacceptable ones are evaluated in more criticality, and in case the NPV is very heavily negative, even if it's a low frequency event, it would be taken quite seriously, and the appropriate action plan would be taken by the company. But on the other side, when I'm looking at the concept of simulation using a stochastic model, it has to be done through a system only. It cannot be a manual process. Whereas here, up to a few number of scenarios, it could still be done in a manual mode also. And for each of them, for each of the variables, there is a distribution or the pattern that is understood, that has to be understood, and randomly the situations need to be simulated, and even the NPVs would be simulated under each of these scenarios, and finally arrive at a distribution of the NPVs. Though in this case the possibilities that are going to occur are very high in number, almost here I don't need to take the estimate expected value like this. I'm going to get a clear cut distribution in this scenario. So it might look that this is very superior process. It is going to yield the most accurate kind of a situation. But we have to understand that everything is based on the distribution that we have assumed. So if our assumptions are good enough, this distribution that is going to get is good enough. So how good are the assumptions that we have made? Only we can tell that. So the assumptions that go into building of this kind of stochastic models are very, very high. And in some cases, because of so many factors to be considered, so much of intercorrelation that exists between the various factors, a modeler typically tries focusing on modeling the minute elements in the process, trying to ignore the key factors. So the key factors that are really contributing to heavily to the NPV, they get ignored. Whereas in a scenario analysis, probably because of the human involvement at every stage, the analyst can quite clearly concentrate on the most important risks and see whether they are getting modeled into the solution or not. But whatever it is, overall it has been talked about that it is always advised that at least create a simple scenario through simulation, but keeping in mind the various assumptions and limitations of the process. But on a simple note, if at all I really want to establish a distribution of the NPVs, I can rely more and more on a slightly simpler approach, which is the scenario analysis, or a completely automated system based approach, which is through simulation, but overall resulting into a better treatment of the NPVs, better evaluation of the project, and better decisions to be taken. All right.